Hey guys, welcome back to the channel. In this video, I'll be just going over a general example for antiderivatives. This is a classic common calculus example. And so before we hop into the meat of the video, please subscribe to the channel and comment down any topics you guys want to see me cover down below. It could be from any subject, preferably it'd be mathematics and physics. And also follow the channel on Instagram at YT_the Swiss Army Tutor. And feel free to DM me or comment on any of my posts, any questions you guys want me to cover. So let's hop right into it. So the question we're trying to answer today is find the most general antiderivative of the function f of x is equal to 9x to the 9th minus 4x is 6 plus 13x cubed. But before we could actually solve this, let's do a little bit of proof. And let's start defining the antiderivative. So the antiderivative is, so we define an antiderivative as the operation that undoes a derivative, but they're not inverses, as seen right here. Okay, but we define an antiderivative as let a function, let f be a function defined on any interval I. And antiderivative of f is on I is a function capital F such that the derivative of capital F is equal to f of x on I. So pretty much what all that's just fancy words of saying that the antiderivative will. So if we were to antiderive this function, we will find the if we antiderive the derivative, we'll find the original function. Alright? And so, essentially, we can conclude the antiderivative undoes the derivative, but there is only one problem. Alright? If we take a derivative of, so, I'm right over here. So, if we take a derivative of a constant, so d over dx, the derivative of any constant is equal to 0. And so, any function like f of x is equal to x, or f of x is equal to x squared, we can have any number plus n, and if we're to find f prime, it would be 2x, still, because that constant's equal to 0. Sorry guys, this constant n will be 0. So how do we account for that? Well, that's where the idea of the indefinite integral comes from, which is, and all it's saying is we're going to cover all of the all of the potential constants that'll give us the same derivative of the function. All right, and so we find this constants. It's commonly denoted by plus c, and we find that c by the second part of the mean value theorem. If f and g are functions defined on an interval, the first derivative of x is equal to the first derivative of g of x. And if this is true, f minus g, so the functions subtracting each other, is a constant. So f minus g is equal to c. We can see here that the function is a given function is equal to a constant plus the antiderivative. All right. So. And from that, we conclude that the antiderivative of f of x is equal to capital F of x, so of little f of x, which will be given this little function up here. The antiderivative, so this will be f. This will be pretty much g. This is capital G. This f of x gives us a. This is just the antiderivative. Okay, plus c. All right, so also, just a note, the antiderivative. So the indefinite integral, or also known as the sum of the antiderivative, or the indefinite integral, as you could say, is not an inverse to a derivatives, and I can prove that in a future video. In fact, when we do cover calculus, I will need to prove that. And I'll show you guys why that's the case. But for power rule, so now, how would we, going back up here, how would we how would we find the antiderivative of this function? Well, we can. So we only have one rule to find antiderivatives, and just some general basic rules for other functions of any other transcendental function. Pretty much the trigonomic, logarithmic, and stuff like that. So the most common is integral of x to the so is the power rule. The integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. So pretty much all we do is, so with the derivative, so d over dx of a function of x to the n was equal to the function so it was equal to the power times times the function with a power subtracting 1. Well, the derivative, pretty much, instead of subtracting 1, we add 1 power to it, and then we also divide by the power, and then we also add a constant because the derivative of a constant is 0. Okay, so let's move on to this problem. Okay, so f of x is equal to 9x to the 9th minus 4x to the 6th, that should be x, sorry, plus 13x cubed. The integral of f of x dx. So we're going to take so this dx pretty much, this means respect to. And so the indefinite integral of f of x dx is equal to the integral of 9x to the 9th minus 4x 6th plus 13x cubed dx. So whatever variable, whenever we integrate something, alright, so if you guys remember the differentials, whenever we derived a function from implicit differentiation, we had a d whatever variable that was. But when we integrate, we need to have respect. So we need to show respect to the to whatever variable. Whenever we integrate a function, we need to show respect to the variable that we integrate by. Sorry for the shakiness, guys. I don't have my camera set up quite yet, my camera mount for this, so I'm just going to keep things the same. Yeah, I'm just holding my phone for now. So we are going to, so like derivatives, we could integrate each term individually. So doing that, so we are allowed to pull this constant outside, and so we have 9x. So we add 1 to the function, so give us 10, or 1 to the power, give us 10, and we divide by that result, 10. 4x to 6 minus 4x, so 4 goes outside. 4x to the 7th, we divide by 7. 13, the constant stays the same here. The multiplying number stays the same. So we keep 13. Add 1 to the function, or add 1 to the power, not function. Sorry, guys. And divide by the outcome, and that's 4. So plus c. And so that lets us know that the antiderivative of this function is 9 tenths x to the 10th power minus 4 sevenths x to the 7th plus 13 fourths x to the 4th plus c. I hope you guys understand now how antiderivatives actually work and where they come from. Just a little bit. I'll go more in depth about it once again, and hopefully you guys understand the power rule as well. Feel free to like, comment, subscribe down below, on the video down below, and I'll see you guys next later. Swiss Army Tutor is out.